Hello everyone, welcome to engineering chemistry class. This is Professor Sudha. Let's discuss about the demineralization process under water technology unit. Demineralization, the term itself has the meaning removal of minerals. The process of removing all the minerals or the ions present in the water is called as demineralization process. In general, the water contains lot of minerals like calcium chloride, magnesium chloride, sodium chloride, potassium chloride, etc. In this process, we are removing all the ions present in the water. The purpose of this process is to convert hot water into soft water, which we can use it for battery purpose, research purpose, and then in inverters. In this process, we are using a resin. The resin plays the main role here. Resin is a polymeric substance which is having functional group. The functional group may be acidic or basic. There are two types of resins, cation exchange resin and anion exchange resin. Cation exchange resins have acidic functional groups having COOH or SO3H groups. They are capable of exchanging all the cations present in the hot water. Examples are sulfonated coals, sulfonated polystyrenes. In anion exchanger, the resins have basic functional groups like NH2OH. They are capable of exchanging all the anions present in the hot water. Examples includes cross-linked quaternary ammonium salts, urea formaldehyde resins. Cation exchange resins are represented by RH2 for easier understanding, and anion exchange resins are represented as R-OH twice. The process. The water is first passed into the cation exchange column. In this column, all the cations are removed by the cation exchange resins. When you see the process, the RH2 which is present in the cation exchanger will react with calcium chloride. The calcium chloride is present in the hot water. The R, that is the functional group present in the cation exchange resin, removes all the cations like calcium, magnesium, sodium present in the water. The leaving behind RCa and 2HCl. In the RH2 react with magnesium sulfate, all the magnesium ions are removed by the R, which is given as the product RMg plus H2SO4. Suppose if sodium chloride salts are present in the water, this R will remove all the sodium ions, giving as RNa and HCl. This is how the cation exchange resin removes all the cations present in the water. Now the cation free water is then passed to the anion exchanger. Here it absorbs all the anions. The anions are negatively charged ions present in the water. When you see here, this R-OH twice will remove all the chloride ions present in the water, giving as R-Cl2 plus 2H2O. Here R-OH twice plus H2SO4 gives R-SO4 plus 2H2O. The water which is given out from the anionic exchanger is called as demineralized water. The water will be free from all the cations and anions. Let's see the construction of the process. This is having two cylindrical chambers. One is cation exchanger, another one is anion exchanger. In the first column we have the cation exchange resin, in the second column we have the anion exchange resin. The raw water is first passed to the cation exchanger. Here the cation exchange resin will absorb all the cations like calcium, magnesium, sodium present in the water. The water which is free from the cations are then passed to the next chamber, that is anion exchanger. Here all the anions are removed here like chloride ions, sulfate ions, all these are removed in the anion exchanger. The water finally which is free from the ions, that is H2O, is called as deionized water or demineralized water. This is how demineralization process we get demineralized water. Next is the advantage of this method. In this method, we can regenerate the resins, cation exchanger and anion exchanger. Cation exchanger can be regenerated by adding dilute HCl, and anion exchange resin can be regenerated by adding dilute NaOH. Let's see the regeneration reaction, just the reverse of the previous reaction. When you see here RCa, when it is added with HCl, what happens here is we get back RH2. This is how we get cation exchange resin back. This is how we regenerate the cation exchanger. Then this calcium chloride is left as such. R Na plus HCl gives RH plus NaCl. R dash Cl2 plus 2 NaOH gives R dash OH twice plus 2 NaCl. Advantages: in this method we can treat highly acidic and alkaline water. Then the water obtained by this method will be having lower hardness. It will be very less than 2 ppm. But there are certain limitations. The disadvantages here are the iron and manganese water cannot be treated by this method, as it causes damage or it will spoil the resin. Also, turbidity reduces the output. The equipment is very costly and the chemicals used in the resins are very expensive. This is somewhat limitations of this process. This is how the demineralized water is prepared, and then we can use it for plenty of applications. Thank you.